Okay, we're ready. Looks like we're on. Good morning, everybody. Welcome to the first session of this morning. Appreciate you being here. We'd also like to thank Couchbase for the opportunity to tell you about what we're doing with Couchbase today. And we'd also like to thank them for this coveted time slot. My name is Jason Williams. I'm principal architect with Cars.com. This is my colleague, Bruce Zawadski, also in our architecture group. And we're here to tell you today about our NoSQL journey with Couchbase. So first, what is Cars.com all about as a company? Excuse me. So if you look at our mission statement is to be the leading decision engine that moves people through the car ownership cycle with transparent, fun, and engaging experiences. And in order to do that, we have to have the best tools possible to manage our data assets. Make sure that we can flexibly evolve them, make sure that we can serve them quickly out to our consumers, make sure that we can ingest all of the data that we need in order to fulfill this mission. If you think about Cars.com from a product perspective, we have three interlocking portfolios of products. We have our service and repair product offering, which is if you need to get service on your vehicle, look for a highly rated repair shop near you. We offer that product family. Similarly, if you're looking to offload your vehicle, get a new vehicle, we offer a family of sell and trade products. And then what you may be the most familiar with is what we call our buy portfolio, which consists of all of our roughly 5 million vehicle listings at any given time, and all of the editorial content, other content around that describes those vehicles. Another way to look at cars, though, from a data architecture perspective, is really as a data processing engine. So on the lower part of this diagram, you see all of the actors in the system at a very high level. So you see we have our consumers, our customers, our partners, our employees. And then on the top, all of the various channels that we use to deliver this data out to those who need it. So our web channel, mobile, API, and then of course through files. We conceptually divide our architecture into acquisition and distribution. And so you can see some of the core entities there that we're bringing in, items such as our listings, customer orders, creating leads, et cetera. All of that data is stored in various data stores and then distributed out in the form of our listings, analytics back to our customers, ad serving, et cetera. So where we found ourselves a couple of years ago is needing to look at something different in this storage layer, right? So what I'll talk about for the rest of the talk is kind of what that journey looked like. So as I said, we saw some opportunities and challenges there. Our current architecture relies on a shared relational database. It has served us very well. But we began to see that there were some opportunities in there to design some things a little bit different. So we'll talk about those. We'll talk about our use cases. We'll talk about our vendor selection process, which I think you can imagine what happened there. And then we will also talk about our initial use cases. So first, what were the challenges and opportunities that we faced? So I've kind of divided it up here from a couple of different perspectives. First, let's look at the business side. First was to quickly onboard new data. I've worked at Cars for a little over 3 years now, and in that time we've started a number of new projects. We launched the service and repair project. We've made a number of changes to our listings. We've brought in new types of editorial data, and each of those required that we evolve data models, evolve schemas, change ETL jobs, and we found ourselves wanting to do that faster than we had been able to before. So that plays into quickly releasing those new products. Our product management organization is like, look, I need to get this out there. I need to kind of be able to fail fast, do something quickly, learn from it, iterate it, get it out there. So that's really kind of where we found ourselves. From an architecture point of view, I really wanted much more flexible data. For example, our classified ad listing. I needed a way to just easily add new attributes to that, have it be consumed by the different platforms. without a lengthy modeling process that was going to break a lot of other things. And we noticed that several things looked like documents in our system if we took back and took a look. Finally, we wanted cost-effective scalability. We wanted a way to scale up with our demand that did not require huge upgrades. So that's another reason why Couchbase was very, very exciting to us. Finally, fast data access, needed things to be fast. And we needed our new data platform to be aligned to our cloud strategy and to our SOA strategy. So we were very excited about things like XDCR, for example, being able to easily move data up into the cloud from on-premise, and just other things about Couchbase that we knew that would make it very easily for us to deploy that in the cloud. Finally, with our SOA strategy, we knew that Couchbase would be a very good tool for us as we began kind of decomposing a couple of our larger databases into smaller databases that we could do as smaller buckets or even individual clusters. So just kind of, what does our data model look like, right? Probably looks very similar to many that you've seen, right? So, and when we look at this, as I said, we see that a number of things just really jump out as things that can be easily modeled as documents. So for example, our vehicle listings, our user profile, our vehicle product master data document, and so forth. And Bruce will talk about all of these. So what were our first use cases? The first one really is our vehicle listings data. We have approximately 5 million listings on the site at any given time. It's a very rich data model that includes a number of facets about the vehicle that you would expect. So what are various options on the vehicle? What's the trim, the make and model? Seller's notes, which is a very free format, very flexible type of data element. Links to images and media, links to editorial content. So that was just a very natural fit for us for NoSQL. Also our user profile, I think a very common use case. One of the things that was very attractive about that is we need that data model to be extremely flexible. For example, we're creating a product called My Garage that lets people come in and tell us what type of vehicles that they have. That way we can set them up for service alerts, et cetera. We can't really control what people are going to want to tell us about their vehicle. I may want to tell cars a lot about the car that I have. You may want to tell us a little. Someone else may want to tell us this or that. We needed something that could just very flexibly grow with that over time. Of course, our product data. We have an offline master data management system. We needed a way to serve that data at scale. So we were looking at Couchbase for that. Also some metrics, which Bruce will talk about. So I don't want to steal his thunder, but we're seeing that as a very promising platform for us for delivering analytic data web scale out to our consumers versus the type of analytic data that's consumed only internally. And then finally, another example of this is our vehicle pricing data. So that again is a use case that Bruce will discuss, but this is an example of a use case which presented as an opportunity that allowed us to move very quickly. So one of the interesting things for me as an enterprise architect is we had planned our NoSQL adoption, and I had planned this rich set of 3 really big use cases that we wanted to go forward on, and we are going forward on them. And then an opportunity presented itself that was not really there at the time of the evaluation, and we were just able to really quickly act on that and get that out and deliver some business value there. So what did our vendor selection process look like? As Couchbase can attest, it was very thorough. And we're very happy with the depth there that we went to. We did a lot of initial research. We looked at some other platforms. We did a number of POCs. We did a series of proposals and demos from 5 different solutions providers, had people out for multiple visits. And then another thing that I just can't stress enough is we relied on Gartner and some other independent research to really kind of vet out this decision for us. So that went really well for us. And then just kind of some highlights of what ended up making this a very good and easy decision for us. First was features and functions. And what we did here is we had a cross-functional selection team. So we had in members of the architecture team, Bruce and myself, members of our engineering team, members of our operations team. So this was really all a decision that we made together. And so once that decision was made, we did not have to go out and really sell it within the organization because we had already done that. So we were really ready to go. So I can't really recommend that enough. But in terms of what really jumped out at us, and this isn't everything, it's just highlights, some features and functions. I particularly, really love and really crazy about nickel. I think it's very important to have that declarative query language, much like SQL, that people know and love. That is really going to help speed our adoption there, and then things that come along with that, such as Query Workbench. Also, the secondary indexes. We know that we're not always going to access our document by key. We will a lot of times, but there are other things that we'll need to be able to do there. And then the MapReduce views. We know that many of the entities that we store in Couchbase will need to be aggregated together in order to make the most use of them. So for example, our vehicle details page, that has data about the vehicle, about the seller of the vehicle. It brings in reviews for the vehicle and reviews for the dealer. So that's a potential use case there where we could use the MapReduce views to create that aggregate view for us. Architectural simplicity was very, very important for us. A couple of things that stand out there, the peer-to-peer architecture, all of the nodes being identical, if you want, but on the other side, having the multidimensional scaling. So that, for example, we could scale up different index nodes as we need to. That'll be very good for us. Performance and high availability. I was very impressed with the memory-first architecture. And then, of course, the cross-data center replication, I mentioned that a little bit. We're using that as our DR solution. And I think that in the future, we'll also be looking at that as part of our cloud solution as a way to help us get to the cloud and then also have multiple availability zones for our data. Finally, the last one that I'll touch on is just the cloud readiness piece. So we have been really, really pleased with the ease of deployment. We've already stood up a couple of test clusters and a couple of different cloud providers. We've been very pleased with how easy that's been to do for us. And finally, as I said before, the document model really aligns to the fine-grained microservices model that we plan on moving forward with. So with that, I'll turn things over to my colleague, Bruce, who will talk about our first use cases.
Thank you. Morning, everybody.
Sure.
Can you share what other products you looked after in your evaluation?
We really can't. We try to keep it focused on kind of who we did select. Speak with me offline if you would like to, and we could give a little bit of information there. Sure.
Please repeat the question if you're going to take them, because for the audience's live stream.
Sure. So just for that one, the question was, are we able to share some of the other vendors that we looked at? We're really not. We make it a policy not to do that. I'd be happy to talk with you a little bit offline about any more of our selection criteria, but we just kind of keep it focused on who we did choose.
Thanks, everybody. Glad you guys can make it out this morning after the election trauma last night. So, I'm on the architecture team at Cars.com along with Jason, and I participated in the vendor selection process, and then I led the rollout of Couchbase at Cars.com. I'm going to talk a little bit about the first cases that we deployed through production. So the goals for our first use case were to really, the main one was to deploy and operationalize the platform with minimal risk. We didn't want to try to re-engineer anything that was critical to our business. So these were new features that we were building. But we wanted to provide a visible business value so that we could prove out the platform. And we wanted to document new patterns and new patterns so that we could accelerate the future development efforts at Cars. And we also wanted to have fun, so we just wanted to create enthusiasm with our developers so that they would be interested in learning about the new platform, so it could be successful. So our first use case actually came out of a hackathon idea. Cars has hackathon competitions occasionally, and this idea was submitted by a coworker. The idea is called the Vehicle Listing Demand Metrics, and it was developed by one of the hackathon teams over several Fridays, and they won the competition and had their code deployed to production. So this is our vehicle detail page on cars.com. We call it the VDP. And this page displays all of the detail about a specific vehicle that's for sale, including the price, all the options, and other details that are related to that vehicle. What we wanted to do was add a new module on the page to display activity on that particular vehicle. So we wanted to add views, email, and saves. So Cars, of course, we track activity off our website for analytic purposes. But in this case, what we wanted to do was to present this back to the shoppers in real-time fashion. The hope was that this would create some urgency and encourage the shopper to select the vehicle and contact the dealer. So the architecture for this, we built some new things into existing stuff that we had. So we already have an activity logging API. That API has the capability to flag bot and scraper traffic when it's detected. And that it streams it to Kafka. So we created a new listing vehicle demand metrics aggregator in Spark. And what that does is it aggregates the specific metrics that we wanted for this use case, and it writes them to Couchbase in a mini batch. So the mini batch gives us the ability to reject the bot or scraper activity. And then in Couchbase, we use Couchbase atomic counters. And what those allowed us to do is it allows us to store metrics for millions of vehicles using only very little memory, since it's just integers with a key. And then we set a TTL on those counters. So the counters will automatically delete or the roll off after we no longer need them. That eliminates the need for us to create a separate batch job to clean up the data bucket after we no longer need that data. And that's it. Oh, then we created a vehicle detail API, which pulls the metrics back from Couchbase and presents them. It's used to present them on our page or on our mobile apps.
Yeah, I have a question.
Sure.
So the images, were you storing that in Couchbase directly, or like just curious about the performance, the images? Or is it a link to a network drive that you're storing in
The
Couchbase?
images?
Yeah.
So we don't store the images in Couchbase. This is, in this use case, just is only specific to the metrics. So we use like a microservice pattern, and we have different services that provide only smaller features on our site. And in this case, this vehicle detail API, this one's just returning the metrics at this time.
Okay.
So there's other composite APIs. This is a simplified view. There's other composite APIs that will pull together all of the detail and build a listing that's displayed on a page.
Okay. Thank you.
So our second use case is Unpacking the Price. And our mission for this was to increase consumer confidence in the vehicle list prices that are displayed on cars.com. And this picture is from an older Super Bowl commercial that we had called Confidence, so you can check that out on YouTube. On our VDP page, we display all of the vehicle features, which are the features that are included in that specific vehicle that you're looking at. But one of the problems with this page is it doesn't show what the prices are or what the MSRP prices are for any of these features. And that makes it difficult for the consumer to know how those features go into making up the overall price of the vehicle. You may see two vehicles that are that look very similar on the surface, but they could have a significant price difference because of the different features. So we wanted to create a new module that would present prices in a way that would provide more price transparency to our shoppers. So the dealers don't provide prices for features. So what we decided to do was we purchased manufacturer pricing data from another partner for the benefit of our consumers so we could present it to them. And this is the presentation that we're using. So what it does is it lists all the prices by feature, and then it breaks it down to a total MSRP and presents it as a discount from the dealer price. So you have something to compare then and look at a vehicle based on features. So the architecture for this, we already have a vehicle listing acquisition pipeline, which is our pipeline for acquiring our listing data from various vendors. We like do an aggregation of vehicle listing data from various places. And into that process, we built a new component to retrieve the manufacturer data from a new partner. That data comes in the form of a large SOAP XML object, which is fairly large. And we do some transformation on that, do some mapping to our own master data, and store it as a JSON object in Couchbase. So the document at the end is about 45 kilobytes in size. And then we have a separate vehicle detail API, which uses Nickel to query only the specific parts of the data of the JSON document that we need for this specific use case. So in this case, we needed just the pricing detail, which is much smaller than the 45 kilobyte document. So we don't have to transfer that whole document across the wire every time for each VDP view. So the benefits that Couchbase gave us here was that normally if we built a solution like this, we would have to store the data in a database, and then we would have to, again, persist the data in distributed cache. And with Couchbase, this really simplifies our architecture since we just write it to Couchbase, and then it's already ready to be used from the inquiry services on our pages. So our experiences with Couchbase, so we've had our code in production for a few months now, and we put together a list of, this is mostly from the perspective of the developers and the people that have supported it as it's gone in, what they liked about it. So we found that learning the basics and getting up and running with Couchbase was easy. So as an example, when we first did our POC, I got together some developers to help with that, and we were able to put together a 3-node cluster, install, get data in it, get data out of it in under an hour. So that was pretty good considering no one knew anything, and all we did was just look on a site and how to install it on Linux and how to configure the cluster. So the automatic in-memory caching really simplifies our architecture. Oh, sorry, this mouse isn't working. This is the mouse. Oh, the mouse is. That's all right. I just look at it. So another thing we liked was the single node type architecture. So the single node type architecture, like Jason described, it allows us, in our case, we have a single chef recipe that we just build out the same exact type of node for every node that we add to our cluster. And it makes it very easy for us to scale out or to build out a new cluster. With some of the other products that we looked at, there were different types of nodes. There's masters or slaves, and then there's nodes that present just the UI for, with the Couchbase node, you have all that built into the single deployable. So that's really helpful. We like that the Couchbase SDK provides us with configurations for timeout and durability options at the client level. That gives us the flexibility to tune those things for each application as we need, versus some other products force you to do it at either at the database server level or at the application server level. So this gives us flexibility. We also like that a lot of our developers, since we're Oracle mostly shop for quite a number of years, a lot of developers that have heavy experience with SQL, and Nickel, is familiar to them, so they're able to pick it up quickly. And we also like that it provides many of the same, even though we were looking for a NoSQL platform, with Nickel, it still provides many of the same capabilities of a relational database if we need them. So overall, Couchbase offered us flexibility, which was what we were looking for with the NoSQL platform. That's it. Any questions?
Right, are there any questions we can answer for you? See one in the back.
Can you share with us the kinds of loads that are being placed on your single node type clusters, and if you plan on going to the multi-dimensional scaling model in the near future?
So we have multi-node clusters. We started out with the first use case, which was the inventory demand metrics. And that actually has a lot of load, even though it doesn't store much data. It was 4,000 operations per second on the cluster. It was a 3-node cluster with 4 CPUs and 64 gig of memory per node. So we built that a little bit more for the vehicle pricing data one, because they're 45 kilobyte documents. So that takes up quite a bit of memory, and it's about 150 gig in memory. It has a much lower operations per second for that use case, though, since we only really retrieve a key value document when it hits the VDP, so that's much lower.
I can speak to the multidimensional scaling piece a little bit. We don't have any specific plans for that at this time, but I can tell you one of the use cases for which it would apply to us. I mentioned, and Bruce showed, our vehicle details page, which is really a combination of information about the vehicle which is for sale and about the seller of the vehicle and some other things. So occasionally information about the seller changes. For example, seller 800 telephone number might change for the routing of calls. Or amenities at a dealership may change. For example, maybe they offer, just as an example, coffee or free oil changes or something like that. So when the seller changes, when that entity changes, we need some way to have that reflected into our vehicle details page. One way that we could potentially do that is with the MapReduce views, creating that aggregate of those entities. And I think that would be a really good time for us to look at the multidimensional scaling piece to isolate out some of the workload of creating that aggregate. Other questions?
Do you have XDCR?
Yes,
we do. Yeah. So we set up our, I didn't go through the infrastructure. I thought it would be more like to present the business cases. But for our infrastructure, we have 2 data centers. And we have a cluster that's set up in our primary data center and another cluster set up in our secondary data center with XDCR going across those. And we have VIP set up so that we could fail over to the secondary data center if needed.
So how much delay do you see usually?
I'm sorry?
How much delay do you see in XDCR, cross data center?
How much do we use it?
Delay. How much delay?
The latency.
The latency?
Across the
it seems very quick because we have with our data center, it's very low latency to it. It's in the same state. It's actually just our main data center is in Chicago, and the secondary data center is just in the suburbs, and we have a very good line there. So we get it's very low latency, but we're not using it as active right now. So it's mostly just for DR use.
Thank you.
Okay, if there's no other questions, I see one. It's difficult to see up here.
Do you guys have any plans of like having any services like a Carfax, internal Carfax kind of feature, instead of leaving the site and going to Carfax? Because I've bought cars on cars.com and I've sold cars on cars.com.
I'm sorry, I'm having trouble hearing.
Like having a feature like a Carfax internal feature, because I know you have a feature to leave the site and go to Carfax.
Yes.
But do you have any plans on using your internal data to have
We do.
something?
Actually, we do use our own internal data for some capabilities that provide historical. So if you look on our research pages, you'll see price ranges. So those price ranges are calculated from our own internal data. So we're doing things with historical price to help consumers get an idea of where the vehicles that they're looking at fall within, whether it's a fair price.
Okay, if there's no others, we'll conclude here. Thank you all very much. We appreciate your time.
Thank you.